Okay, in this video we're going to take a look at the definitions of the set operations that we see here, as well as talk about ways of checking that something is actually in or not in the sets. And these are very related, so I'll kind of do 24 and 25 together. First, the definition of A union B. That's a set of all things such that X is in A or X is in B. That's the formal definition of a union. So therefore, if I want to show that something is part of the union, then I should show that X is in A or X is in B. So that's how I would check to see if something is in this union. It's in one set or the other set, possibly both. The negation would be, if I want to show that something's not in the union, I would need to take the negation of that, so that X is not in A and that X is not in B. So that's the way that I would check to see that X is not part of a union. Okay, next, intersection. A intersect B, the definition is the set of all X such that X is in A and X is in B. So that's the definition of intersection. Therefore, if I want to show that something is part of the intersection, I would need to show that X is in A and that X is in B. If I want to show something that is not part of the intersection, I would need to show that X is not in A or that X is not in B, just simply taking the negation of this and statement. Okay, third, the set difference. A minus B, that's the set of all X such that X is in A and X is not in B. So all the things in A, but I take away the things that are in B. So if I want to show that something's part of the set difference, I would need to show that X is in A and that X is not in B. If I want to show something is not part of the set difference, then I would need to show that X is not in A or that X is in B. If either one of these or both happens, then X is not part of the set difference. Part 4. A complement. The definition of a complement is that's a set of all things such that X is not in A. So if I want to show something as part of a complement, I would need to show that X is not in A. If I want to show that it's not an element of a complement, then I would need to show that X is in A. So that would be the complement ones. All right, now for this infinite union, this is the set of all things such that X is in A sub I for some I. Or perhaps written like this, that X, set of all X such that there exists an I such that X is an element of A sub I. Okay, so that's the definition of this infinite union, that it's a set of all things that is an element of at least one of the A sub i's. So coming down here, if I want to show that X is an element of this union, I would need to show that X is an element of A sub I for at least one of the indices I. Conversely, if I want to show that something is not part of this union, I would need to show that X is not in A sub I for all I. Okay. Last, the infinite intersection. This would be the set of all things such that X is in A sub I for all I. Or written more compactly, the set of all X such that for all I, X is in A sub I. Okay, so I'm looking for all things that are in every single set. Therefore, if I want to show something as part of this infinite intersection, I would need to show that X is in A sub I for all I. The negation of that, if I want to show that X is not part of this infinite intersection, I would need to show that X is not an element of A sub I for some I, that there's at least one set that does not contain the proposed element X. Okay, so that's so problems 24 and 25 are very much related. The formal definitions of these operations, as well as how to check that something is or is not part of those sets.